Hi, thanks for joining the session. I'm Adithya. I'm from the Azure product group. I help customers migrating their workloads to Azure, and I've been working with many customers around the world across different industries in complex PostgreSQL implementations, and I've been helping them in resolving their performance and scalability issues. A little breakdown of the session for the next 20 minutes. I understand that this is very limited time to deep dive into each of these topics, but what I would like to do is talk about the key challenges, solution, and outcome of a couple of engagements. And I believe that this would be very useful for anyone who's considering to move to PostgreSQL from Oracle. So this session is mainly targeted for anyone who wishes to migrate to PostgreSQL from Oracle. Many customers I work with are migrating to PostgreSQL from Oracle. Let us look at what their reasons were to migrate to PostgreSQL. One of the main reasons customers migrate to PostgreSQL is because it is open source. And open source solutions often give customers the freedom to choose, and it allows them to manage the software in-house. This avoids dependency on a single vendor. Ultimately, because of this, there is a reduced total cost of ownership because there is less cost for software acquisition, there is less cost for maintenance and support. And this, in turn, contributes to lower total cost of ownership. There is a lot of flexibility when it comes to PostgreSQL. So PostgreSQL's extensibility allows customers to add functionality without any vendor restrictions. And because it's open source PostgreSQL, customers have access to the source code, they have full transparency. It allows organizations like big banks, financial institutions to modify and customize software to meet their specific requirements and goals. And talk about Postgres. Postgres very well integrates with a lot of tools, platforms, and other technologies. So its ability to easily integrate with other tools and platform helps customers to easily integrate with their platforms. We all know the amazing PostgreSQL community, and they are very active, they provide support, and they try to improve the engine all the time. So my customers, including me, I'm actually amazed how active the PostgreSQL community is. In most of the cases, if you have a query, you drop down a question in the community DL, you're sure to receive a response within an hour or less. And that's how amazing Postgres community is. So it is not easy to migrate from one database technology to another. We all know that. And with migration comes a lot of challenges. These are a few key challenges that come to my mind when it comes to database migration. The schema migration and the data migration being one of those. So the schema migration is quite a challenge because they pose several issues during migration. The most common is not setting the right data types between the source and the target during migration. Usually, when you don't set the right data types between the source and the target, what happens is it is a possibility that there is a miss in precision, and that can lead to data truncation. And there are cases where the data types are mismatched. And after migration, what we find is that in PostgreSQL, the table explodes because the size of the table is far more huge than what you observed in Oracle. Then after migrations comes the challenges of missing indexes. There's always a possibility that the queries after migration start to run slower in PostgreSQL. And after investigation, you find out that there are missing indexes. You have to apply those indexes. So that's also a possible challenge. The data migration itself is a big challenge when it comes to migration because the time taken to migrate is directly proportional to the size of your database. So it is always a challenge when it comes to data migration. And if you have a lot of Oracle packages in and you are using a lot of Oracle native features, then that also becomes a challenge because once you migrate to Postgres, you will have to rewrite those Oracle-specific queries into PostgreSQL store procedures and PostgreSQL supported features. There are always query syntax differences as well. For example, in order to select top 10 rows in Oracle, you would use a row num, where row num is equal to 10. But then when it comes to Postgres, you'll have to rewrite that to use a limit. And there are joins as well, which Oracle supports and which are not supported in Postgres, which you'll have to rewrite. And talking about performance is also one of the key challenges when it comes to migration engagements typically. So when, of course, customers achieve a huge cost savings when they migrate off Oracle and migrate to Postgres, but without performance on par or better than Oracle, the whole business case of migration becomes a moot point. And it is only fair that customers expect that their performance is on par or better than Oracle once they migrate to Postgres. So in most cases, this becomes a challenge because after migration, customers find that the performance is not on par with Oracle at times because of the way the queries are written. And like I mentioned, there are indexes missing, statistics needs to be applied. But in most cases, application and databases will have to make some adjustments in order to ensure that the queries are on par with Oracle. And after they have done those changes, in most cases, we find that the performance is on par or better than Oracle. The next key challenge is testing. I cannot stress the importance of testing in a migration engagement because there is change of code involved. So your application goes through change of code. Your database objects have changed. The data types have been mapped. So a thorough application testing is very much needed in case of a migration project. Most of the mission critical applications require minimal downtime, and they need to have a right fallback strategy in place when it comes to data migration. So that is also one of the most key challenge, most common challenge in terms of migration, because customers need to run both these platforms in parallel for some time in case of mission critical applications. And in case there is a failure, they need to fall back to the original system. They should be able to fall back to the original system in case something goes wrong, so that they can reattempt the migration at a later point in time. So this is always a challenge to keep two systems alive for an extended period of time. Fortunately, we have some great tools in the marketplace to do it, like Stream, like HVR, that can be used to keep both these environments in sync. So there are many more tools in the market which customers use, but these are a couple of the tools that I've seen many of the customers use. Now, let's look at some tales from the field. So the first story I would like to talk about is a bank from Southeast Asia. They run a trading application that is highly transactional in nature, and it processes, and the trading application actually processes 1 million messages per minute. The key challenges that the team went through was mainly data type conversion. So they had complex Oracle data types, specifically hierarchical data types, and they had to change this to PostgreSQL and required significant effort. And one of the key challenges that we faced during that migration was that they had a 2 terabyte table in Oracle, and after they migrated to PostgreSQL, the customer was shocked because the same table was now 10 terabytes. So basically, this I would like to tie it back to the point that I raised before about data type mapping. So after investigation, the customer found out that the Oracle table was compressed, and in Postgres, the table exploded basically because of the incorrect data type choices they had made and the ordering of columns. And they were not able to use of the native dose compression that is applied in Postgres because of the incorrect ordering of columns. So that was one of the key challenges that we faced with this customer. Like I mentioned earlier, performance testing is one of the key aspects of migration. After migration, this customer ran multiple cycles of performance tests in order to ensure that the queries performed on par with Oracle. So after migration, the customer identified top N queries that like a comparison, and they ran it on Postgres, and they found that those queries were not working or not performing on par with Oracle. So then there were multiple performance test cycles which the customer had to go through in order to ensure that the performance was on par with Oracle. One of the cool tools that they used during the performance test was pgBadger. So pgBadger is an amazing log analyzer tool that comes handy during performance tests. It is an open source tool, and it gives you a detailed report on the top N queries and the detailed stats about those queries, why they are performing slow. So I'll drop in the link for pgBadger here, and maybe it will be useful for your performance tests. And the approach that the customer took was a phased migration approach. So what they did was, at the start of the migration, they prioritized all their critical applications, and they approached. So they had a number of databases which had to be migrated, and a number of applications, of course, to be migrated. So what they did is that they prioritized in a way that they picked up the smaller applications or less critical applications first. And as part of this, they established a process in place, like a migration factory process in place, where they identify the tools and technologies required for migration. They set up deployment pipelines, and they did an iterative approach to the whole migration. This actually helped them because of that, they gained confidence and experience in that process, and they were able to use the same learnings that they got in migrating those smaller database and apply it much better and much efficiently in the migration of the larger database. The other thing that they did was they were always engaged with the PostgreSQL community. So whenever they hit a blocker in terms of PostgreSQL, or they had a question regarding performance or monitoring or any relevant PostgreSQL topic, they would drop down an email to the PostgreSQL mailing list, and the community is pretty active, and they would receive a reply or a feedback instantly within probably a few minutes, or maybe even less than an hour. And that helped them to gain confidence and get expert assistance when it comes to Postgres related topics. So the result of this was the customer achieved huge cost savings because of this migration, because there was significant reduction costs in Oracle licenses, and the performance was significantly improved because of the number of performance tests that they had carried out. They ensured that all the queries were tuned, all the queries are performing on par with Oracle. So they were able to actually achieve better performance than in Oracle after migration, after they did all the tuning and fixes. So now let's look at the other customer. The other customer that I would like to talk about is a media company in Europe. The main driver for their migration was that they wanted to adopt open source technologies, and they wanted to avoid vendor lock-in. They migrated from Oracle as well and they also wanted to reduce cost, of course. And they also had a lot of AI-related workloads that ran batch processes, which drove advertisements. And they had a lot of data ingestion pipelines which would run in overnight batches. And there were a lot of analytical queries that were executed overnight. And the interesting fact about that was they had batch processes run overnight and produce reports, which was sent to top level management for decision making on a weekly basis. So you can imagine how data accuracy is so important for this customer, because you could imagine, important decisions are being taken by top level management based on these reports. The main challenge this customer had was the SQL syntax differences. And in reality, databases don't exist in isolation. They exist in solidarity between a lot of applications. So there are a lot of applications that connect to a database, and they had applications running in .NET, Java, and these applications had embedded PL/SQL queries. So that was one of their main challenges, because they had a lot of applications which had embedded PL/SQL queries. So as part of the migration, what they had to do is they had to change these applications, which kind of was a difficult one, but they were able to do it. They knew exactly what had to be changed. They used tools to sniff out PL/SQL, embedded PL/SQL code, and then change it into PL/PG/SQL code. The other challenge that they had was database schema conversion, because in Oracle, they had multiple databases, and they had to migrate this to PostgreSQL into different schemas. And they had a lot of cross database queries as well. And this was a challenge for them, because they had queries which used to run across DBs. Now their applications had to remove all of that dependency, because it used to query multiple databases. Now it's all residing in a single database, in a single schema, and they had to do some refactoring based on that. But this is a challenge specific to this customer. So that was also a challenge that the customer had. What the customer did was that they automated the whole migration process into deployment pipelines, and they created APIs using Ora2PG, which used Ora2PG behind the scenes, and they kind of automated the entire schema and data migration. This is really cool, because then they were able to use Ora2PG, and they were able to fire those APIs that they built on top of Ora2PG and fire database migration in an automatic fashion in demand for all of the other databases. It's kind of helped them to make the migration faster for the other databases. And they had also implemented comprehensive testing to ensure that the application functionality post-migration was working exactly the same way as it used to work before, along with performance. Because remember, like I told you, there were many applications which were connecting to the database, and they had to endure a lot of application code changes because of those embedded PL/SQL queries. As a result of this migration, they had a reduction in cost. So they had substantial savings on the database fees, because now they didn't have to pay anything for license. They also gained operational efficiency, because they had developed the deployment pipelines, automatic deployment pipelines. And so they could create these migrations faster. They could basically do these migrations at a faster rate, and using Postgres, they were able to actually achieve better performance than Oracle. One of the most common and interesting observation from both of these customers is that in the beginning, both of these customers wanted to migrate to Postgres in a virtual machine. So both of them executed a POC, migrating from Oracle to PostgreSQL in an IS machine, in a virtual machine. But then eventually, along the way, after they reviewed the requirements related to high availability, DR, and about how they could scale this environment and all of that, they discovered that they could adopt cloud, and they basically understood that it would be much easier for them if they just moved to a PaaS service. So they chose Azure PostgreSQL Flexible Server as the target. So they did a quick POC soon after they tried. So first they tried migrating from Oracle to PostgreSQL in a VM, and then they understood that the parity between Postgres in a VM and the managed service that Azure offers is pretty much similar, and both of them run on open source Postgres. So they did a POC with managed Postgres, which is Azure Postgres for Flexible Server, and they understood that the whole management of the database was extremely simplified, because now they understood that they don't have to do operating system patching, they don't have to do updates, minor updates on their Postgres version. All this is managed by Azure. They understood that they don't have to do any kind of backups, because again, the backups are automatically managed by Azure platform, and the backups are snapshot based. So they could actually do point-in-time restore to any point in time if they wanted to. So in case there is an issue with the database, in case they have corrupted the data in the database due to their pipelines, it's an easy way to just restore a copy of the database from point-in-time restore, through point-in-time restore. So they understood all of these points, which kind of was very convenient for them, and they could also scale their workloads independently because it's a managed service and scaling is instant. You can basically scale your services according to the needs of your workload, and also they have read queries which can be forwarded to read replicas. So it is possible for them to now stand up a read replica, and redirect their read queries to the read replica with a click of a button. The same thing goes for disaster recovery. They could create cross-region read replicas and they could use it for disaster recovery purpose. And in terms of high availability, it became much more simpler, because you always have a hot standby and automatic failover, because you are now moving to a PaaS service. So these are a couple of decision factors and a couple of things which they observed after they did the migration to PostgreSQL in a VM, and soon after they decided that Azure Postgres Flexible Server was the right target, because that reduces their operating costs by huge, and that reduces their total cost of ownership significantly, because now they didn't have a team. They didn't have to have a team looking after the resource 24/7, managing the update cycles and so on. So that was something that was pretty much common between both of these engagements. And with the managed service, they also got extensive monitoring and analytics capabilities, which they could leverage. So there is log analytics and the query store, which they could use in order to do extensive monitoring of the resource. And that also integrates very well with their dashboards, with their monitoring dashboards, existing monitoring dashboards, and centralized monitoring system. So they are able to manage all of their requirements successfully. So a few tips and tricks, and to summarize what we have covered so far in the session. So the key thing is that we need to identify the top queries as part of the planning. So that was one of the key things that we need to do as part of Oracle to PostgreSQL migrations. You can get the top queries from your AWR. Those can be taken as a baseline or a benchmark to assess your performance after migration. And this is what both of these customers did, and this is what most of our customers do. They analyze the top N queries. You can get it from an AWR report, and then ensure that after migration, these top queries are run in PostgreSQL, and the performance is basically measured against those queries. And right sizing is another critical factor that needs to be done. So you need to look at the AWR report, understand the key metrics from AWR report like IOPS, CPU utilization, RAM utilization, and then map it to the relevant SKU so that your target is appropriately sized. And you can get these details from the AWR report too. I cannot stress enough about the multiple performance test cycles. So you'll need to run multiple performance test cycles in order to ensure that your queries are performing on par with Oracle or better than Oracle. And this is what we have seen with most of the customers, and this is what has worked well for many customers to ensure that you run multiple performance test cycles, because it is possible that after migration the queries are not performing up to your expectation, and then you need to basically iteratively fix them. It is a possibility. So highly recommend to run multiple performance test cycles in order to ensure that you get the performance that you expect after setting the right target skew. And if there is an opportunity, leverage the power of cloud. Like I mentioned about automatic backups, OS updates, patching, high availability, disaster recovery. There is a lot cloud can offer, a lot that Azure can offer. All of these tasks are simplified when you move to cloud. So that is some of the key learnings that we take from customers, how their process is simplified, how they are able to scale up because of cloud, because of Azure. Because what we've seen with the customers is that their operations have become massively simplified because they have chosen a managed service. And coming to data migration, use of tools like Azure Data Factory will help you templatize the data migration to come up with a way to parallelly migrate the data and scale the data migration. You could use this. You could use Data Factory. Data Factory is an ETL cloud-based ETL tool in Azure, and there are templates available online which you could use to basically load many tables in parallel. One of the cool tools that my customers use to ensure that the data is successfully migrated from source to target is the data comparison tool. And I leave the link to the tool here, and it'll also be there in the description. So the data comparison tool is a tool developed by one of my colleagues. He calls it data comparison tool, simple as that. So what it basically does is it compares data between the source and the target and gives you a report if the data matches between the source and the target. This is very handy when it comes to ensuring the data data integrity checks after migration. I'll share these links in the description. These are a few pointers and important links that would help you in your migration journey. I'll leave them in the description as well, and you will get them in the copy of my presentation. So with that, we have come to the end of the session. Be sure to visit the links that I've shared earlier. And last year in CitusCon, I spoke about migrating partition tables from Oracle to PostgreSQL. In case you are interested in that topic, in case you would like to watch that topic, you can watch it here. That link will appear here, I guess. And I'll also leave it in the description. We've also published a detailed migration guide at docs.migration.com, which also has scripts that you could use in your data migration journey to successfully migrate from Oracle to Postgres. And I'll leave the links in the description as well, and it should appear somewhere here. So feel free to reach out to me in case you have any questions regarding Azure Database for PostgreSQL or Oracle to PostgreSQL migrations. I'll be happy to answer. Send in your questions over email. You can see my email on the screen, or hit me up on LinkedIn. Hope you're enjoying Posette. Thank you for joining.